So for the first question, we're going to take a look at writing a formula to predict the terms in a sequence. First thing you want to do is number your terms so you can see how many you have, and that's going to also help us to test the formula once we come up with it. So this is the first term, second term, third term, fourth term. So our goal is to see if we can find a formula that would predict the terms without us having to keep doing it manually. So the first step is trying to look for a pattern. Does anybody see the pattern to get from 8 to 11, 11 to 14, and 14 to 17? Yep.
Add 3.
Add 3. Does anyone remember what kind of sequence that makes it if you're adding the same number repeatedly? Yep.
Oh, that's it?
Yep, you could say arithmetic sequence or an arithmetic sequence. And the common difference is 3. 11 minus 8 gives us 3. 14 minus 11 gives us 3. 17 minus 4 gives us 3. It's always adding 3. And what's the first term in our sequence? 8. So there's a formula that uses these two values. You fill them in, and then it will give you the answer that we're looking for. Does anyone remember the formula for an arithmetic sequence? Yep.
It's a sub 1 plus parentheses n minus 1 parentheses and then d.
Times d. And what does that give you? What does it equal?
That equals the
Like what is this formula used to figure out?
the rule of the sequence. So
Yep, so we just need to put something on this side. This formula calculates the, yep,
is it an?
yeah,
A sub n.
it calculates the nth term in the sequence. Okay, so now let's fill in the two values and see if it works. So the first term is 8. And the common difference is 3. What do we get when we distribute out the 3? Yep.
8 plus 3n minus 3.
3n minus 3. And when you combine like terms, what do you get for your final answer?
5 plus 3n, or 3n plus 5.
Yeah, I'm going to write it as 3n plus 5. And now let's check it. And the hope is that if we plug in 4 into that formula, we get 17. What's 3 times 4? Yeah,
12.
12. And what's 12 plus 5?
17.
Perfect. So now when you plug in that number, the formula gives you that number. And that's what they're looking for. So the formula is 3 times n plus 5. Let's look at the next one. That's it's a little bit different. It's not arithmetic. Does anyone see the pattern for that one? Yep.
Multiply by 2.
Yep, multiplying by 2 each time. What do we call the 2? It's not the common difference. It's the... Yep.
Is it the rate?
It does begin with an R, not rate, but it's the common... Is it an R? What do you call when you divide like a fraction? Yep.
Is it the common ratio?
Ratio. Yep. Common ratio. So our R is 2. And what's the first term in the sequence? 7. So now there's a formula that's going to work because we're multiplying each time. That makes it geometric. We need the formula for a geometric sequence. What's the formula for that? Yeah.
A sub 1 times r, and then x1 and n minus 1.
And same idea, what's going to go on the left side?
A equals a sub n.
Yeah, that's to calculate the nth term. Okay, so fill in our values. First term is 7. Our value is 2. And let's check and see if it works. So the idea is number your positions. let's check 3. If we plug 3 in, we hopefully will get 28. 3 minus 1 gives me how much? Yep. 2. And what's 2 squared? Yep.
4.
And what's 4 times 7?
28.
28. That's exactly what I was supposed to get. So now you've got a formula that if you plug in the position, it'll automatically calculate the term in that position. So that's finding an explicit formula. All right, so the next question we're going to look at is determining if a sequence of numbers converges or diverges. If a sequence of numbers converges, that means the numbers themselves are getting closer and closer to 1.
The converges are getting closer and closer to 0.
Yes, the numbers are getting closer and closer to 0. And then if they are getting closer and closer to 0, then we can find the limit, which means to add them all up. So let's look at the first one. Do you think this sequence converges or diverges? Yeah. This diverges because the individual terms are not getting closer to 0, they're getting bigger and bigger, which means if you continue these terms forever, they're just going to get bigger and bigger. They're not going to add up to a number. It adds up to infinity. So any question on why this is divergent? Diverges. Okay. So because it diverges, there's nothing to add up. Let's look at the one on the right. What about that one? Do you think that one converges or diverges? Yep.
Converges.
That one converges because the individual terms are getting closer and closer to 0. What are you doing each time to get from one term to the next? Yep.
Dividing by 2.
Okay. Can you describe it to me in terms of multiplication?
Multiplying by 1/2.
Right. So when we look at our R value, R has to be what you multiply by each time. Try to think of it that way rather than division. So the R value here is 1/2. And the first term is, yep,
40.
40. So we just said it converges, which is correct. And what is the formula that we use to figure out what it converges to?
A sub 1 over 1 minus 5.
Yeah, so we got to use that formula and then fill in our values. So A1 is 40 over 1 minus 1/2. What's that going to come out to when we simplify 40 divided by 1 minus 1/2? Yeah, 80, because that's going to be 40 divided by 1/2, which comes out to 80. So if you were to continue this sequence forever and add up every single term in the sequence, it would approach 80. 80 would be the limit. Okay, so for the next problem, they want us to list the terms in the sequence. I've given you 2 kinds of sequences. The one on the left, anybody know the word that describes that kind of sequence? Yeah. It's explicit. You can find any term you want by directly plugging in the position of that term. So, to find the first term, you plug 1 in for n, and then you go from there. What do you get for the first term if you plug 1 in for n on the left column? Yeah,
You get 5.
you get 5. That's your first term. How about your second term? Yeah. 8. And I said we'll do the first 5. Okay, what's the third term going to be? Yeah.
11.
11. And fourth term? Yeah. 14. And one more, we'll do the fifth term. That's going to give us
17.
17. So that's listing out the terms using an explicit formula for a sequence. Okay, now let's take a look at the one on the right. The one on the right, that's a different kind of formula. Does anybody remember what kind of formula that's called? Yep,
Recursive.
that's recursive. So recursive means you do something to the term before to find the next one. So you can't just jump to like the 50th term here. You would have to find the 49th term and then all the way back. What is this rule basically telling you to do? If you had to describe that in a sentence to someone, very simply. Yep.
Take the previous term and subtract 5 from it.
Yes. To find the next term, take the one before the one you have and subtract 5. So, what is the first term in this sequence? Yep.
4,
And how do you know that?
because it's given.
It's given. In a recursive sequence, they always give you the first one. Now, follow the pattern of subtracting 5 each time, and that will give you the next term. Okay. So what's the second term going to be? Yeah, -1. And the third term? Yeah,
-6.
-6. How about the fourth term? Yep,
-11.
-11. And again, we'll just do one more. Okay, the fifth term.
-16.
-16. So that's listing terms from both a recursive and explicit formula. Okay, so the next one we're going to look at is a summation, and they want us to write this in a more compact way. So they want us to write it in sigma notation. First of all, is the summation we have up there finite or infinite? Yep.
Finite.
It's finite. So when we write it in sigma notation, we shouldn't be using an infinity at the top. This doesn't go on forever. So the first thing we need is a number that we're going to start at. What is the most common number we use for the starting index? You don't have to use this number, but it might make it easier. Yep.
1.
Okay, so we're going to start at 1. And now, what number would we have to stop at to generate 6 terms?
6.
We have to stop at 6. Now, we need a formula in that box that when we plug in the number 1, we get a 6. When we plug in a 2, we get a 12. When we plug in a 3, we get an 18, and so on. Anyone think they see the formula that would generate those numbers? Yep.
6 each time.
Okay, you are adding 6 each time. So can you give me a formula with K in it? That I could plug in a 1 and get a 6. Yep.
Would it be 6 plus K?
Well, if you did 6 plus K, when I plug in 1, I get a 7. And now when I plug in 2, I get an 8. So it's not 6 plus K. Yep.
6K?
6K, yes. Now, when I plug in a 1, I get 6 times 1. When you plug in a 2, you get 6 times 2. 3, 6 times 2. So that is exactly what they were looking for right there. That's how you convert from expanded notation to sigma. Any question on that? Okay. How about the reverse? Any question on how you would take sigma and change it back to expanded? Yep.
I'm still a little confused about the top part with the number 6.
So the top part when you plug this number into a formula, it has to give you that result. The top number is the last number that you get.
Okay.
So if you plug in 6, 6 times 6 gives me the last number. Yep. If you stop at like 5, that wouldn't work because that would give me this number. So we got to go all the way to 6. How about if I had if I wanted to expand that out and change it from sigma to expanded, what number would we start plugging in for k? Yeah, 1. And we plug it in, write it down. So 3 times 1 is 3. 3 plus 1 gives me 4. And then what's the next number you plug in for k? Yep, 2. And what do you get if you plug in 2 for k?
7.
7. Okay, we need to keep going until we get to the top number. So plug in 3 for k. That's going to give you how much? Yep.
10.
10. And we got one more number to plug in, 4. That's the final stopping point. Yep.
13.
That gives you 13. And now if they wanted you to add that all up, let's see, so 4 plus 7, it's going to give me 11. 11 plus 10, 21. 21 plus 13 is 34. So that's how you change sigma to expanded. Okay, so for the last question for 11.1 and 11.2, finding the sum, find the sum of the first 5 terms in this sequence. They didn't give you the terms, so you have to find them yourself, and then you just have to add them up. So how would you get the first term in that sequence? Yeah.
You'd plug in 1 for n.
Yeah. And what do you get if you plug in 1?
Negative 1.
Yep. So 3 times 1 is 3 minus 4 is negative 1. And what would the second term be in that sequence? Yep. 2. And the third term in the sequence? Yep. 5. Okay. Fourth term in the sequence? Yep. 8. And the fifth term in the sequence? Yep.
11.
11. So now it said to find the sum. We're not going to use any fancy formula, we're just going to add them all up. So negative 1 plus 2, it's going to give us 1. 1 plus 5 gives us 6. 6 plus 8 gives us 14. And then 14 plus 11 gives us 25. So that's finding the sum of terms in a finite sequence. So next question we're going to look at is evaluating a factorial. So remember, factorial means to multiply every number from the number they give you all the way down to 1. So how would you write 7 factorial out completely without the explanation? Yep.
7 times 6 times 5 times 4 times 3 times 2.
Yep. Yeah, you could put the times 1. We don't have to, but we could. So that's small enough. We could do it out. We also on the calculator can use the factorial. Do you remember where the factorial button is on the calculator? Yep.
Is it in the math?
Under math. Yep.
That's pretty far down.
It's not under the. You press the math button, but it's not in the math menu.
Is it complex?
Nope. There's nothing. I've actually don't really use much in there. We could, but no, it's not under complex. Probability. And then it's the fourth option. So when we do that out, we get 5,040. So factorials are going to grow pretty fast, so we're going to have to reduce them when we do combinations. But for that, that's all you have to do. All right, so the next one we're going to look at, this is evaluating a combination. So remember, this would be giving us in the 9th row of Pascal's triangle, the fourth column over. So we'll be calculating that number. This top value is usually associated with a letter. Anybody remember what letter we use for the 9?
N.
That's an N. And the bottom number? Yep.
R.
We use R. And this is pronounced 9 choose 4. It's one way you can say it. Now, to figure that out, rather than drawing all 9 rows of Pascal's triangle, we're going to use a formula. And anyone remember the formula for evaluating a combination? Yep.
N factorial over, in parentheses, N minus R, and then factorial, R factorial.
Yes. Okay, so let's fill that in. And remember, we are going to try to reduce what we can. Even though the numbers aren't that big here, you could run into numbers that are too big to do on the calculator if you don't reduce the way I'm about to show you. So we've got 9 factorial over N minus R factorial. So that's 5 factorial, and then R factorial. Okay, if we wrote out everything in the top, a lot of it would cancel with something that's in the bottom. When we write out 9 factorial, everything from what number down would cancel? Yep.
5.
Everything from 5 down. Because this is 9, 8, 7, 6, and then times 5, 4, 3, 2, 1 is going to cancel with this 5, 4, 3, 2, 1. So that's completely gone. The 4 factorial is still in the bottom. Because we're dealing with a combination, you never get a decimal. Everything in the bottom has to cancel out with everything in the top. So how can I start to reduce this?
Well, the 2 and the 3 at the bottom cancels out with the 6 at the top.
So 2 times 3 is 6. Now, there's only one thing left we can do.
8 and 4.
Yep. And that gives us 2. Okay, so now we have to multiply what we have left. We have 9 times 2 times 7. I think it's going to be easier to do 9 times 7 first and then double that. What's 9 times 7? Yep. 63. And if you double 63, you get
126.
126. Okay, so had you tried to deal with the number 9 factorial, I mean, that's a pretty big number. 9 factorial, well, it's 5,040, that's 7 factorial. And then it's multiplied by 8 and by 9. So that's not going to be an easy number to work with in your head. But if you reduce it, it's much easier. All right, so this one is asking us if we did out the expansion to find the 8th term. If you expand something to the 13th power, do you remember how many terms you get? Yep.
14.
14. You always get one more. Right? So what I'm going to do, just visual to help me, is I'm going to draw out the 14 terms. 1, 2, 3, 4. There's the 14 terms. And when we start counting, what number do we always start with? Yep. Well, to use Pascal's triangle, though.
For exponents?
No, just thinking of numbering these.
Oh, 0.
Right, we always start with 0 because that's the way Pascal's triangle works. If we don't start counting with 0, it messes us up. So the term that we're looking for is the 8th term. So 0, 1, 2, 3, 4, 5, 6, 7. That's the one they want. Okay, just to be clear about that piece. Okay, what row in Pascal's triangle would we need to know to find that coefficient? coefficient would be in row. Yeah, it would be in row 13. And what column would it be in? 8. Well, doing the triangle out to the 13th row is going to take a long time. So we need to figure it out using the method we did here. So we're going to look for the coefficient in the 13th row, 8th column. So we have to figure that out. It's probably going to be a pretty big number. And then, what's going to go inside this first set of parentheses? We don't know the power yet. We can figure that out.
2x.
That's going to be a 2x. And inside the second set of parentheses,
Y.
it's going to be a y. Now we need the powers. If I started with my 2x term here, what would be the power on the 2x in the first spot? Yep. It would have been to the 13th. And then it would be, what would happen each time to this 13? Yep.
It would decrease by
It would
1.
decrease by 1. So then it would be to the 13, 12, 11, 10, 9, 8, 7, 6, 5. So we know it's 2x to the 5th. And now that we know that's a 5, what would be the exponent on the y?
Eight.
8. So the quick way is we know these two numbers have to add up to 13. So once you know one of them, you automatically know the other one. Okay. Now it's just a matter of doing this out. So let's figure out 13, choose 8. So 13 factorial over, you tell me what's going to go in the bottom. Yep.
5 factorial, and then 8 factorial.
And then 8 factorial. Okay, while we're here, let's finish that piece off, and then we'll come back to the rest, which is, that part's pretty easy. Everything from what number down in the top for 13 factorial is going to cancel, yeah?
8.
Right, we can always cancel it with the bigger number. So we're still going to be left with 13 times 12, 11, 10, 9, but 8 all the way down is gone. And in the bottom, we were left with just the 5, 4, 3, 2. Okay. Anyone see what we can cancel out there? Yep.
The 4 and 3 can cancel out with 12.
4 times 3 is 12. Yep. Yep.
5 is
And 5
5 and 2.
5 times 2 is 10. So now you're left with a much smaller calculation. 11 times 9 is 99. I need 99 times 13. Not that big, but big enough we can use our calculator. So 1,287. Okay. So we got the number. Now what's 2x to the 5th? Is that
36.
No, 36 isn't a power of 2.
Oh.
Yep.
32.
32. So 32x to the 5th, y to the 8th. We'll need a calculator, but what would be our last step there? Yep.
Distribute the coefficient, like the, sorry, the 1,287.
To what?
32x.
Would you distribute it to both the 32 and the x, or just the 32?
Just the 32.
Right. So it's really just a multiply. Just 1,287 times 32. And again, not that huge, but big enough we can use the calculator. 41,184. that is the 8th term if you were to do all of that out. That's what you would get for the 8th term. Okay. Any question on that? So last question is expanding a binomial. And when we only have to do it to a power that's like 6 or less, we really want to be able to use the triangle because that's going to be a lot faster than using the formula. So what row do we need to know up to in Pascal's triangle to do this problem? Yep. 5th row. And what do we call the top of the triangle? What row is that? Yep. Row 0. Okay, so really we've got to make sure we go down 6. It's going to be 6 levels in the triangle because the first level is row 0. So we got 1. 0, 1, 2, 3, 4, 5, and that's it. I have enough to do the rows. Any question on how to generate that triangle? That I have memorized. I wasn't really doing calculations to figure it out. If I started to go down like 3 or 4 more rows, then I'd have to start thinking about adding the 2 numbers above it to get the number below it. Okay, so now when we expand it, remember you're going to get 6 terms. 1, 2, 3, 4, 5, 6. Each term has a coefficient. Let's write those down. What's going to be the coefficient of my first term? Yep.
Oh wait, sorry, 1.
1.
Yes, okay.
And the coefficient of my next term?
Five.
5. And my third term?
10.
10. Fourth term?
10.
10. So we've hit the halfway point, so now it's symmetrical. 1, 5, 10, 10, 5, 1. Okay. Now we have to put each of these factors to powers. So the first one is going to be an a to the what power? 5th, and it's going to be a b to the 0. So we don't need b yet. Okay. Next one. A is going to be to what power?
The
4th, and the b
to the first.
to the 1st. Remember, these 2 exponents have to add together to give you 5 in this problem. Okay, next one, 10, and what are going to be my letters? A to the 3rd, B to the 2nd. Okay, and the next one, 10 again, but my letters this time are going to be, yeah,
A squared and B cubed.
A squared, B cubed. And second to last term, coefficient's 5, and the variables will be
A to the first and B to the fourth.
A, B to the 4th, and in the last term, yep,
B to the 5th.
1, B to the 5th. So that, again, it might not seem like it's, it's super easy at first, but it is a lot faster than writing A plus B 5 times and foiling them all together. It's just a pattern, and once you know the pattern, it's relatively quick.